what it is, and how to use it. Then I will talk about the serial interface converters, why we need them, what they do, and their specifications. Finally, I will talk about troubleshooting and the most common problems and how to fix them. The 4 to 20 milliamp current loop is used to convey logic 0 at 4 milliamps and logic 1 at 20 milliamps. This allows for greater distance than the EIA-232, which uses voltage instead of current. It also offers higher noise immunity, but slower bit rates. The 4 to 20 milliamp current loop transmits a signal from sensors and instrumentation to controllers. Typically, this is seen as printers and terminals in the industrial environment. While 0 to 60 milliamps is an also acceptable range, 0 is not preferred due to the ambiguity of an open circuit, as well as being able to use the 4 milliamps to power the device. Many companies still have the EIA-232, but the industry has moved on to the EIA-422 and more recently the 485. The most common converters are the EIA-232 to 422, 485, and current loop. These converters are used to increase the range between two EIA-232 devices. The EIA-232 to 422 and the 485 both provide bidirectional full duplex conversion for either synchronous or asynchronous transfer. However, the 485 allows for multiple devices and is backwards compatible with the 422, which only offers control over one device. Both may be powered by the EIA-232, but an external power source is recommended as the EIA-232 was not designed for power supply. They both also offer optical isolation, which is recommended for long-distance operations due to lightning striking the ground and causing differential. Specifications for the EIA-232 to 422 and 485 are a 1 megabit per second data transfer rate, DCE to DTE switch selectable. It converts all data and control signals, is powered by an AC source, offers optical isolation, and has DB25 and DB37 connectors for both male and female. The specifications for the EIA-232 to current loop are 20 or 60 milliamp operation. Again, the DCE to DTE, but however, full or half duplex selectable. They offer active or passive loop support, also have the optical isolation option, is powered from an AC source, however offers a data rate of 19.2 megabits per second over a much larger area of 3 kilometers. However, it only offers the DB25 connector in male or female, but also has a current loop connector of 5 screw. For troubleshooting, both are very similar to troubleshooting the EIA-232 device as well as the EIA-485, with the exception of making sure to take extra care in a non-isolated converter where electrical surges may occur. Also, avoid loop-powered EIA-232 to 485 as it is unreliable. As I said, the EIA-232 was not designed to supply power to devices. Ensure the converter is powered. If it is not, the LED will not be lit green and may indicate that the unit is damaged or unplugged. If all connections are made, then every LED except for the receive and transmit should be lit. Connecting these two together and then running a protocol analysis program should cause the two related LEDs to begin flashing. For network transmission, this LED will be lit when the EIA-485 converter is active and driving the network. Only one unit should be driving a multi-drop network at a time, otherwise it will cancel each other out. For the configuration jumpers, these are often set internally. However, some units allow for user configuration. The assertion of the request to send protocol is used to place the EIA-485 into transmit mode. The failsafe termination is a jumper that decides what happens when the EIA-232 host becomes disconnected. Usually, this is set to be disabled when disconnected, and the network transmit LED should turn off. For the digital ground shield, noise rejection performance can be enhanced by grounding the digital logic pin. However, this is a last resort and should be only checked after everything else has been run through. For a few applications of these devices, they provide conversion from a serial network to other medias. They are also useful for any system using an EIA-232 that does not want to upgrade to newer hardware, but still needs to be able to communicate with devices that run the EIA-422 or 485. Also, they are great for providing long-distance communication as well as multi-device transmission. Thank you for listening. That was my presentation.